Okay, let's continue our discussion with an example. So we have a water which is flowing steadily in a zero point 0.4 meter wide rectangular channel at a rate of zero point 0.2 cubic meters per second, as you can see in the figure. So 0.15 is the depth, and the width of the that's the depth of the flow, and the width of the channel is 0.4. So we have to determine uh, if the flow is subcritical or supercritical. Then also we need to determine um, the flow depth if the character of flow were to change. So if it's critical or supercritical, kung ano sa atong ma-find out, then if ingnan na to nga sige atong siyang we will let the flow ato siyang i-adjust ang flow nga or atong i-design ang flow para it should be critical or subcritical siya. Then pila man dapat ang iyang depth di ay sa flow. So ano atong i-figure out. So water flow in a rectangular open channel is considered. The character of the flow, the velocity, and the alternate depth are to be determined. So the assumptions, the specific height is constant. So most likely, most cases, constant man na iyang specific energy. So the flow velocity is determined from this one. So actually this equation is just kuan siya over a, actually Q is kuan V is volumetric flow or the discharge or the Q. So Q over area is just equal to 3.33 meters per second. Then the critical depth of the flow, so we will plug the numbers to our equation. So for rectangular channel, so the critical depth is 0.294. So okay, so 0.294 ang yung critical depth. So the flow is super critical because ang iyang critical depth is 0.294, but ang iyang actual depth is or nasa to yung D is only 0.15 meter. So mas gamay siya og depth, meaning kusog ang iyang velocity. So it's super critical. One way to find out is to solve for the Froude number. So by solving the Froude number, it's above 1. That's the Froude number is 2.75. So it's clearly a supercritical flow. So maman to ang question, determine it's critical or supercritical. Then pila man iyang alternate nga flow if gusto ta nga we know that it's supercritical. If you want it nga subcritical siya o critical, how much man dapat ang iyang flow. So for the flow to be supercritical, F1 is or Fr is greater than 1. So constant ang iyang specific energy. So we'll first solve the specific energy. So muna ang equation. Specific energy, so 0.7163. Gamiton na to ang specific energy because it's constant. So mamuntay second question, alternate depth will be determined. So constant ang iyang specific energy, but this time atong i-unknown ang iyang y. So mo na siya dapat ang y sa atong flow nga dili siya mag supercritical. So in that equation, the only unknown is y. So dapat ang flow din is 0.69 para dili siya mag supercritical. So therefore, if the character of flow were to change from supercritical to subcritical while holding the specific energy constant, meaning constant ang iyang specific energy, meaning equal ra gyapon ang iyang Q, same ra gyapon ang iyang Q. So the flow depth would rise from 0.15 to 0.69. So mahitabo gud ani mo rise ang flow, mo dako ang area, mo hinay ang velocity. So constant ra gyapon ang iyang Q. Okay, so any question for the previous, and if you have a question, you can comment in the reply portion of the post na may question for that particular example. Okay, so we will proceed. We mentioned in previous discussion that flow in a channel is called uniform flow if the flow depth is constant, diba? So constant ang iyang area, constant ang iyang velocity. Uniform flow conditions are commonly encountered in practice in long straight runs of channel with constant slope. So kini nga mga portion in yung long straight runs of channel with constant slope, kuha ni siya nga man-made channel, artificially made channel like canals or irrigation or pipelines carrying water or carrying oil. So mga man-made structures, because for natural channels you cannot find a constant slope or long straight channel. Di na siya mahitabo, di na siya, never na siya mahitabo sa actual kana pa constant cross section. So it can never happen in actual. Maybe there was a time inana siya, but mukuan na siya. Natural flow of channel is ang natural ana niya nga characteristic is kuan na siya, it's meandering, magliko-liko na siya. That's the natural flow of the channel. So the flow depth in uniform flow is called the normal depth, and the average flow velocity is called the uniform flow velocity. The flow remains uniform as long as the slope, cross section, and surface roughness is unchanged. Yeah. So in uniform flow, the flow depth y, the average flow velocity, so kung constant sila tanan, so ano siya, constant sila tanan, so ma-equate ang iyang head loss sa iyang elevation loss. So dulhogon, mga magana siya, constant ang iyang slope, so dulhogon siya, then mo kuan man na siya, mo normalize man ang iyang flow, mo uniform ang iyang flow, bali ma-equate ang iyang flow, ang iyang energy, in change sa iyang elevation. So due to gravity, then ma-equate sa iyang friction resistance. So manang constant terminal mo ang iyang velocity mo, di siya siyang terminal velocity, so constant velocity. So itong ma-equate ang head loss o ang elevation loss. So di ba mo mani ang atong head loss sa atong previous discussion. So instead of head loss, head loss manghapon, but ato mag-equate ang iyang elevation loss. So di ba elevation loss is slope times the length, so mo siya ang vertical nga distance. So instead of hydraulic diameter, atong tang hydraulic radius, mo man na sa open channel. So mahibong mga anong 8 na ni siya, 2 ni siya, 8G na siya because hydraulic radius is 4 times less than the hydraulic diameter. So expressing or solving the relation of velocity, so the velocity is equal to this one, c the square root of slope over RH. RH is ano siya, hydraulic radius, that's equal to area over the weighted perimeter. So volumetric flow or Q, multiplyan na nato og area ang velocity. So cross-sectional area times the velocity. So mo na siya ang Q. It's the volumetric flow. So kini siya nga factor this is the called the Chisey coefficient. So it is named it's because it was developed by Antoine sana ni basa Antoine Chisey. So it was named after him, and the C is called the Chisey's equation, Chisey coefficient. Okay, so since the introduction of the Chisey's equation, considerable effort has been devoted by numerous investigators, by scientists and engineers, to the development of simpler empirical relations of the average velocity and flow rate. So the most widely used equation was developed by Gauquelin, Philip Gaspard Gauquelin, and independently also developed ni Robert Manning. So both Gauquelin and Manning made recommendations that a constant in Chisey equation be expressed as this one, or A is factor man na siyang A due to English and SI units. So, si kuan mo gud si Gauquelin, he's using an SI, then si English, si Irishman, si Robert Manning nag-use na siya og English na system. So na siya factor ang A. N is the Manning's coefficient, and R, simply R, is the hydraulic radius. So it's the Manning's coefficient, N. So velocity, mahitabo na ang velocity is ano siya, Manning's equation is ano siya, A over N. R, or in other books actually R lang ni siya, or in this book RH 2/3, then ang slope is 1/2. That's the Manning's equation for velocity. Multiplyan na siya og area, so mahimo na siyang Q. This one, volumetric flow, naman siya AC. Okay, so kung English ang atong unit, so ang A mahimo siyang 1, na siya value nga 1.846. Kung SI, so it's simply as 1. So kung SI siya, it's just 1 over N. Kung English, 1.486 over N. Okay, so mo ni siya ang typical value or estimated value for the Manning's coefficient. So another scientists and engineers, nagdevelop siya sa ilang value sa C. So kang Gangley cutter C, so nasa siya iyang C. So taas-taas na siya. So actually it's still a function of Manning's end and slope for SI and for imperial unit. Okay, so maulang gyapon na siya R, actually RH na siya this book. S is the slope, R is the hydraulic radius, and N is the Manning's coefficient. That's the cutter C, or Gangley cutter C. So na po is C, i-develop si Basin. So simple niya ha. It's just equal to certain constant over 1 plus m over square root of r. At ang m niya is napod siya value, but siya gibuhat nga m. Wa siya, this equation wala siya nagamit og Manning's n, but instead nagamit siya iyahang value nga m. Okay, so example, I will just cut this video. I will put the video of the example in a separate video.